In the Beginning, Compelling Evidence for Creation and the Flood by Dr. Walt Brown, page 140. Upward, upward buckling, figure 65. The floor of a limestone quarry buckled upward in Yorkshire, England in 1887. The explanation is quite simple. Shale, which lay beneath the floor, consists of plate-like particles that can slide over each other like playing cards in a deck. The weight of the quarry's walls squeezed shale toward the center of the quarry, increasing the upward pressure on the quarry floor. Once the slightest buckle began, the limestone floor weakened, allowing the shale to push up even more. In the flood cataclysm, the quarry was about 60 miles deep, hundreds of miles wide, and 46,000 miles long. The high pressure on the exposed portion of the subterranean floor was no longer balanced by the weight of the crust pressing down. Therefore, that portion of the chamber floor increasingly bulged upward, as happened in the quarry. Eventually, the hydroplates, still supported by high pressure water, began to slide downhill away from the rapidly rising bulge. This removed even more weight from the chamber floor, accelerating its upward bulging. Today, the upbuckled region is the globe encircling mid-oceanic ridge. Mechanical and civil engineers call this phenomenon the buckling of plate on elastic foundation. I have demonstrated this to hundreds of audiences. Place long bricks on top of a foam mattress that is horizontally compressed in a rigid box. Then slowly remove the bricks from the foam mattress, beginning at the center and moving outward. When enough bricks are removed, the mattress suddenly springs upward, raising the remaining bricks. If these bricks were a frictionless surface, such as water, they would accelerate downhill just as continents, hydroplates, did during the continental drift phase. When the hydroplates crashed hours after the continental drift began, mountains worldwide were buckled up and wide ocean basins opened up. Although this void opens up under the unbuckled foam mattress, Although a void opens up under the unbuckled foam mattress, no void would open deep inside the earth because the pressures are too great. Consequently, high pressure rock from below would buckle up to fill the space. That would leave a void farther down because even deeper rock would be squeezed up to fill the space. Ultimately, mass from the opposite side of the Earth must depress to compensate for the rising mid-Atlantic ridge and the entire Atlantic floor. Therefore, the Pacific and Indian Oceans rapidly formed. Evidence and details are given on pages 163 to 201. Okay, so ultimately, mass from the opposite side of the Earth must depress to compensate for the rising mid-Atlantic ridge and the entire Atlantic floor. Therefore, the Pacific and Indian Oceans rapidly formed. Evidence and details are given on page 163 to 201. Continental drift phase. Mid-Atlantic ridge, continental drift phase. Uh-oh. Birth of the Mid-Atlantic ridge and the upper slippery slope. And the birth of the Mid-Atlantic ridge and the ultimate slippery slope. Ice is slick, especially if one is on ice skates, because as long as ice is directly under the great pressure of the metal blades, the ice normally turns to liquid water. So ice skaters are actually sliding on liquid water. Imagine how fast a skater or a hydroplate would slide down a mountainside the size of the Mid-Atlantic ridge, whose surface was 50 times slicker than liquid water. Supercritical water has a viscosity, frictional resistance, about 1/50th that of normal water, so supercritical water provided almost no resistance to the massive sliding hydroplates. It was much like riding on a cushion of air. Later in this book, we will calculate the speed. If you haven't studied figure 52 On page 127, the answer will surprise you. Contrast with the century-old problem geologists have trying to understand how the rock in massive continental plates can scrape over and through mantle rock, which is a solid, not a liquid. Obviously, the plates cannot. Geologists have a serious problem. In the Beginning by Walt Brown.